Okay guys, here we're going to do a solving equations review in absolute value, and we're going to do one equation and one inequality. So if you remember from absolute value equations, you have a positive case and a negative case that are going to be true for this equation. Because of the absolute value is a measure of distance, then whatever is inside the absolute value is going to always be positive. So when this is equal to 23, it will be true, and when it's equal to negative 23, the equation will also be true. That's why we've set up the two cases here. Once we get the absolute value by itself, then you just set it equal to the positive 23 and the negative 23. So when I solve these and I add 7 to both sides, I have negative 3x equal to 30. And that will be true when x is negative 10. So there's half of our solution. Now, students have a tendency to do this, and they'll solve this, and then they'll say, okay, this is where I do positive negative case. Now, the solution is negative 10 and positive 10, which is incorrect. And if you put that back in the equation, you would see that it does not work. So when I put negative 10 back in, I get 30 minus 7, which is 23. Absolute value 23 equals 23. If I put a positive 10 in there, positive 10 would be negative 37, and that is definitely not going to equal 23 even after we take the absolute value. So don't make that mistake. You have to break the positive and negative case up once you get the absolute value by itself. So we'll do the negative case here, and negative 3x, add 7 to both sides, equals negative 16. Divide both sides by negative 3, and you have another solution of 5 and 1/3. So when I put 5 and 1/3 in for x, I'm going to get negative 16 minus 7, which is negative 23, and the absolute value makes it positive, so then that would also be true. So your two solutions here are negative 10 and positive 5 1/3. Let's move over to the inequality and take a look at how to solve that. So what we did for this was we ignored the inequality sign and just made an equation out of it and solved it like it was an equation. And what we're going to do then is we're going to get two critical values to put on a number line. Those will be our boundary points. So if we solve both positive and negative case here, positive case, we're going to subtract 7 from both sides. So 2x equals 8 when x equals 4. So there's one of our boundaries. We subtract 7 from both sides over here, and we're left with 2x equals negative 22, which leaves us with another critical value of negative 11. So there's your boundaries. And what we're going to do at this point is we're going to put those on a number line. I'm going to do a better number line than that. Okay, so we just make a simple number line. It doesn't have to be numbered really or anything. And there's just 2 points on here. Doesn't have to be perfect, doesn't have to be accurate. So I'm just going to put negative 11 here and 4 here. Now, since it's inclusion, less than or equal to, I'm going to color these points in because they are included in the solution. And now I'm going to test the areas between and on the outside of the points. So an area in between the points that would be easy to check is 0. 0 is between negative 11 and 4. When I put 0 into my original inequality, I get 0 plus 7, which is 7. And the absolute value of 7 is definitely less than or equal to 15. So once I tested 0, it made the inequality true. So that means all the points in between negative 11 and 4 are my solution for this absolute value inequality. Now, just to show you, any point less than negative 11, let's say negative 12, negative 12 would give me negative 24. Negative 24 plus 7 would be negative 17, and that's definitely after the absolute value. So if I put that in there and I get negative 17, the absolute value will make it positive, and positive 17 is not less than 15, so therefore we are false. Any value less than negative 11. The same will hold up for any value greater than 4. Let's say 5. If I put 5 in here, 5 times 2 is 10, plus 7 is 17. That's also greater than 15, which makes our inequality false. So you'll see here that the values for which this works are in between negative 11 and 4. Now, the last step would be to actually write an inequality that represents this. So this would be any number x that's greater than or equal to negative 11 and less than or equal to 4. So there are two examples for solving absolute value equations and inequalities, and I hope that helps.